Please.
Okay, so thank you for the introduction. As you mentioned, we are going to show you how to use DODAS generated cluster to analyze your data, to provide resources and software solutions to analyze all your data stored somewhere else or inside the cluster itself. First of all, a disclaimer to this presentation will be heavily focused on user point of view, and it will be separated in two parts. The first one is about an introduction to the core concept of DODAS solution, and the other one is the actual demo showing the main feature of the system. There are a few main objectives that I hope we'll achieve during the presentation, and the first one is make you understand and look at the customization possibilities that DODAS offer for your community perspective, and also illustrating the currently supported solution, in particular the data access patterns. And finally, I will demonstrate the possibility to bring together and customize a system integrated with both batch and interactive solution for analysis. So what's DODAS? First of all, the acronym says Dynamic On-Demand Analysis Service. It was initially prototyped back in 2017, and in the context of the Indigo Data Cloud project. The primary use case for which it was born is about the dynamic resource provisioning for the CMS experiment, in particular targeting the utilization of opportunistic computing. Well, since then, it's quite been evolved, both in terms of supported use cases and communities. In fact, we will see later that there are different kind of flavor that we propose for the communities, and also in terms of adopted technologies. We are moving toward a thinner layer and a more flexible layer on top of a generic Kubernetes cluster, but we will see in a while with this. So the fundamentals behind the DODAS solution can be summarized as this one. First of all, the purpose is to enable users to create infrastructure deployments without needing too many sysadmin skills, and being able also in this manner to deploy its favorite solution for analysis or for data access on more or less any cloud provider with almost zero effort. And to do that, we easily make use of automation solutions. But we saw during this period that this shares a lot, I'd say, of common objectives with any cloud native initiative around the world, also at industry level. So we decided to converge toward the most used solutions part. So we decided to create a layer on top that can be plugged on top of any Kubernetes cluster. That, as you may know, is, as a matter of fact, the standard container orchestration tool by now. And this was particularly useful because allows us to facilitate the modernization process inside the communities. We see that applying and using standards, de facto standards, help us a lot in this process. And finally, as you can imagine from this description, all these has the effect to effectively decoupling the deployment from the infrastructure provisioning. So in this case, we will focus on understanding how one community can reuse general building blocks built for other communities' needs. So in this way, I mean, here in this slide, promoting the reuse of computing solution. Well, talking of standards and how we implement things, well, if we want to template the configuration for a service, for a DODAS service, of course, our choice went to Unchart. So in our terminology, a DODAS service is in fact Kubernetes and chart. All these charts are collected on a dashboard that allow the service composition game that we will see in a bit. And this is particularly important because each one of these charts can be integrated with each other to satisfy the needs of the user. And in particular, this can be done also from a graphical user interface that is made using Bitnami Cube apps. You can know about, but we will see later. And that can also be deployed on any Kubernetes cluster with an Unchart, so in an easy way, and is integrated with OpenID Connect IAM authentication authorization. The lower layer, so the layer behind this, is basically everything that can provision resources via Kubernetes clusters. So in particular, we have an automatic way to provide all from the graphical user interface to the bare method or VM needed, integrated in the Indigo PaaS orchestrator, but can be run also on Kubernetes with some more steps, few more steps on public cloud and made clusters, Kubernetes clusters deployed locally or on your favorite VMs, let's say. And the other part is instead the software part. So what we can plug in, what we actually plugged in our solution. So all the user management, authentication authorization is performed so far with Indigo IAM. That allows also the federated model, for example, with HTCondor, and also support capabilities-based authorization. The compute resource orchestration, as I told you before, can be performed or with a manual orchestration, let's say, or in an automatic way with the Indigo PaaS or the infrastructure manager. The data access pattern, finally, we support X3D and S3 mainly. X3D in particular, we have recipes also for the caching mechanism, so we can set up cache servers on demand. While for S3 storage, we use support MinIO. Software distribution, that's also the other nice thing. Basically, all our supported solution can be configured to automatically mount a CVMFS repository on all the resources. So you can share your particular software on all the resources with a simple enabling flag. So in summary, what is the core of the configuration and templating of all the services, DODAS services? Well, it's basically an Unchart repository integrated in all the machinery I told you before. And in this particular case, the chart repository of DODAS provide few of the most common needed solution that we found from our communities that are an on-demand Jupyter Hub instance integrated with a batch system, that in that case would be HTCondor. We also have the very same setup with the distribution of software via CVMFS, reading data, experiment data via S3 storage via MinIO, or through the data caching XUT, as I mentioned before. So the demo will heavily focus on understanding how you can leverage the graphical UI to combine this solution together to get something that is really tailored on your needs. Okay, so let me summarize again what are the main combination that we use and we serve to the communities. The first one is a simple pool of nodes, worker nodes, HTCondor worker nodes, that can be attached dynamically to an existing experiment pool of resources. And as you remember, maybe the initial aim of the project was to provide this kind of solution for CMX experiment, for example. So attaching new resources, dynamic resources, to an existing pool. Then we have also instead some dedicated services, so fully integrated services, where we can provide a sort of a user analysis facility toward a Jupyter instance integrated directly with a dedicated batch system. This batch system can come again in two flavors, one with software mounted via CMFS, and also reading data through a local dedicated S3 storage. So what are the demo steps for today? I'll guide you quickly through the authentication and authorization features of the composable catalog of DODAS. And then we are going to instantiate an HTCondor cluster that you can access also from outside and launching some jobs. And then we are going to match these two on Redbox. So we are going to integrate, configure Jupyter Hub to launch notebook that automatically can connect and interact with the HTCondor cluster. So it's demo time now. Let's cross our fingers. And I don't know, how do you want to proceed? If there are already some questions that I can go through, or we proceed directly with the demo?
Are there any questions? You can raise your hand.
Oops.
There are no questions at the moment. Probably people thinking.
Okay.
Please.
Okay, so let's get our hands on, so maybe we'll be more clear what we are talking about. Okay, so this is a test instance that I deployed for the occasion, and as I mentioned before, the whole stack from Kubernetes cluster is being made using infrastructure manager, for example. And if you can see this screen, we can log in into the master node with this convenience script provided by DODAS, and in a while, should appear the login node. Oops. Okay, clear. And then, just to let you understand that I'm running on a multiple node instance of Kubernetes. Okay, you're almost there, sorry. Okay, so I list all the nodes that are part of the Kubernetes cluster. You see that there are 10 nodes Kubernetes cluster. And everything was set up automatically, as I mentioned before, through infrastructure manager. Now, let's get back, and on this cluster is instantiated this service. As I mentioned before, KubeApps. That will be the graphical user interface that you can use to deploy and combine your solutions. As you can see here, you can access via OEDC provider, and in this particular case will be the IAM instance, DODAS instance. You can log in with your credential, and you will be redirected to this page. So for whoever has a bit of practice with Kubernetes, each user can be designated to different namespace, so it can work atomically with respect to all the others. In particular, I have already set up a demo namespace. So we are going to work on this namespace, but the important thing I want to highlight is that whether the user can access one namespace, can access a certain kind of resources on this cluster, can be configured, can be dependent on the basically authentication service used. So you can base the namespace you can see on the on a token scope or in user groups. So only members of certain groups can access defined Kubernetes namespace. In this case, I have this namespace, and I can take a look immediately to the catalog of services that I have. So we can go to stable and DODAS, and you can see that are the service that we provide out of the box. So you can see that there are the configuration, experiment-specific configuration that we will see later that are basically what is called an umbrella and chart that combine in different flavor HTCondor and Xcache, HTCondor and MinIO, or HTCondor and Jupyter Hub as a service. For the purpose of the demo, we are going to firstly going to deploy an HTCondor cluster. So we can click on this icon, and we are prompt with a README of the chart, where we explain all the values, or we should explain better, but the idea is here you understand how the chart works, and then you go to deploy. On deploy, you have a lot of already predefined fields that you need to define if are not already there, and we'll custom your let's say customize your cluster deployment. So you will have a shared secret for authentication between daemon in HTCondor. I don't know, it's not needed that you know all the details of this, but the nice thing here is that you have predefined fields that you can fill up. I can put here the demo secret, no problem with that, it will be internal. And then you should pass your public IP of your service. In this particular setup, I need this, but if you have any different ingress configuration or particular setup of your cluster, you can be obliged to change this in some ways. But for now, let's see what we need. So we pass the public endpoints of our cluster here. Same here for the schedule components. And then you can also select the kind of volume you want to put on the schedule, or anything else can be tuned via these tweaks, basically. And you see also here the number of worker nodes and the size of them. So first thing, you can start, fill all these fields, and click deploy. Now, it will try to contact the Kubernetes cluster and deploy your application out of the box without any further intervention. And you will see also that you can monitor the advancement of the deployment toward this UI. And you see, in fact, that here you have all the resources that are going to be deployed, and it gradually grows up until completion. Now, so far so good, already deployed. And a few more things about this deployment. You can scroll up and check whatever you want to check from command line if everything is okay. You can have also look at all the configuration that you just deployed and the complete set of values passed for the configuration. You see that what we tuned before, that is these few fields, are a subset of all the configuration you can put inside this chart. And the configuration you can put inside this chart are here. Okay, so here, if you're a more advanced user, you can enter and set up your cluster as you want. Okay, so just go back to application. And now you see that on the application tab, you have your own HTCondor cluster that is configured as before, and that's fine for us. You can also, as I already done, put in upgrade and update the configuration, and we'll be dynamically update your configuration. We will see this in a while. So first of all, let's check if everything went well for good. We can type a quick check from the command line of Kubernetes. So asking kubectl get pod in the daemon namespace. And you can see that in fact, worker nodes, KD, and all the components needed are running. So now I said that we'll be user focused. How you can use it is how you can access and submit jobs to this cluster that you wrote up this simple from an external machine. Well, let's try this out. I'm going to log into an LX Plus machine at CERN, so outside my cluster. And okay, maybe with the right password I can log in, okay. And then I have prepared for this demo a folder containing basically, well, I can do cat, an environment setup for my HTCondor cluster, where you can see that I'm passing here the addresses of the components I just brought up. So these are basically the entries I put in here. You can check that are effectively the same. And then I can source in this way, source HTC RC. And I need just one more thing to set up before being able to contact the server. The authentication authorization service accepted by the cluster brought up in this way is through OEDC access tokens provided by Indigo IM. So what I need to do is basically using OEDC agent or whatever method to get a valid OEDC token. I can do that with this command that I set up before. And I obtain this kind of token that I simply need to copy, and let me clear the screen to be clear, and attaching this to a token file. So I cancel the previous one and I insert my token. Insert, save, and then if the God demo assists me, I should be able to see the Condor cluster. Yeah, that's what we should see. So we see that one worker node is registered to the cluster and is up and running. If I want, for example, just let me refresh this page, okay? If I want to upgrade my cluster and, for example, putting 10 worker nodes, I can do this, upgrade. Oops, sorry, the token was almost gone. Let me redo this. Upgrade and 10 worker nodes. I scale up the worker nodes, and now you will see that it will appear a new configuration with worker nodes increasing, and not immediately, but in a while, I should be able, to see my worker nodes increasing here. You see now are 8, and now slowly, will grow till 10 worker nodes. I can also submit some jobs to demonstrate that everything is working. So I have a submit file with some basic configurations, and I'm going to execute a job, an executable called simple with these outputs. And the simple executable will be simple as this, of course, as the name says. So sleep 100 seconds, and then, well, let's do sleeps, 100 seconds, okay? And echo the host name of the worker nodes where the jobs will run. To do the submit, I can do, let me clear the screen again. And to do the submit of the job, I can do condor submit minus spool of sub. So submitting, and here you are. We can check with condor, condor Q that the jobs is running. No, it's right now it's in idle and will be start going in running in a while. So we can put a watch here and let it run. So it's running. So it's waiting 100 seconds and will close up. I take the occasion also to show that if I go to upgrade, I can not only change from this menu, not only change the number of worker nodes, I can change also the size in case I need multiple CPUs or more memory. And also I can use, you can see here there is our user image, for example, that you can use your own image. Of course, it has to have the HTCondor correct version to be run. Other important things, I told you before that you can change values from YAML here in order to be more advanced. And in fact, what you can change here, you can see that you can change the map file, the authorization, basically all this could be. You can change a lot of other things, but you can also enable new features. Like, for example, let me find it. Here you are. You can enable the CVMFS mount on all your nodes. So far, it's disabled, but in a few seconds, I will show you how you can enable on all your worker nodes. So this is the running, should be almost done by now. And let me 100 seconds. Okay, so it's done. You see it's in completed state. What I can do now is transfer the output, Condor transfer data, oops, Condor transfer data of the job 1.0. So fetch all the data, and now on my directory, I have the 3 files of output, and I can print out the output of the batch job. That is basically the host name of the worker node where the jobs run. Of course, you can understand the importance of this. It's quite good to have a solution for providing a cluster and be able to access from outside. It's also more interesting if on the worker nodes you can find your favorite software via CVMFS, for example. So we are going to do this right now. And what we are going to see if everything will work is that we can change the simple file in this way. So we can say, okay, we don't need to trust it running anymore. So we can comment out the sleep part and say, okay, let me see what you see on /cvmfs. Okay, cvmfs. Okay, so we are good to go. And first of all, we need, of course, to bring down our worker nodes. So from 10 replicas, we put down and we say, hey, 0 replicas. So we bring down our worker nodes because we are going to generate a new set of worker nodes with CVMFS mounted on top of them. Okay, so that's all. And let's go and enabling, oops, sorry about this. Okay, enabling CVMFS. I have my experiment CVMFS. I have, for example, this CMS and grid CVMFS repository. And I indicate enable true. So I deploy. And it's taking a while because it's setting up the CVMFS, as you can see here, component on all the nodes. And then, okay, I'm good. Let's bring up again 10 worker nodes. So I could have even have made this in one step from command line, but yeah, you see it's not a big effort to do. So worker nodes are coming up. And well, now just check that Condor status just wait a bit. Okay, like give it some time, maybe it's coming back up. Maybe not. Is it possible that token is expired? Probably yes, because I didn't specify here how much time should be valid for the token, so sorry about that. I simply take another one and I put back in token. So this step can be automated, of course. If you have an agent, NoDC agent on this machine, I could put a cron tab or something like that to keep my token file valid inside. And okay, so the machines are ready. My simple executable, if you remember now, should print also the content of all the CVMFS folders. and we are ready to submit a new job that this time should be quite instantaneous. And Condor Q Condor should say okay, idle, and should start quite soon. Take the occasion of waiting to understand if there are any questions so far, curiosity, whatever.
It seems no.
Okay.
Question. It's very clear. Seems everything clear.
Wow. Yeah. Let's suppose that. Yeah. Okay. So, come on. Well, it's happening is probably, yeah. Okay. So it's ran and completed. Let's gather the output of the job 2. And if we cut simple the, oops. (2.0), okay. Okay, didn't work. Let's check why. ls cvmfs. Okay, let's try this again. Maybe I did it too fast and something went wrong. So let's take a while. Well, you know, like them are like that. And okay, so let's bring down again our worker nodes. And while this is running, we go ahead with the demo and then we come back to this. So now is 0, give some time to digest this. And as I told you before, we can set up a Jupyter Hub instance via this icon that is ready to be used with this description. The README here is a bit better. And you can deploy with few additional steps. So a name for the deployment would be JHub. We will use the custom name. Well, this depends on your DNS. This is ours. So, okay. And we also, so you see there are no other option back here. If you put enable HTCondor integration, you will be prompted with 2 additional steps. And one step is indicating where the HTCondor collector is running. Oops. HTCondor collector is running and schd is running. Then the final endpoint for the redirection after the authentication. And finally, to interact with the IAM, we need an access token, a valid access token that we can get from here. So we get an access token to be passed here to allow the whole machinery to bring up the authentication properly in Jupyter Hub that will be done once again with the same IAM server. So field, okay. We are ready to go. We put deploy, and this will bring up a Jupyter Hub instance where you can log in, do whatever you want to, being able to also interact in a seamless way with a just deployed Kubernetes HTCondor cluster. So you can see here now in application, in a while, yeah, it's going to start and do its things. And we see that another service appeared on the application tabs. So now let's go back to HTCondor and upgrade. So let's bring up the worker nodes again. Okay, let's check that CVMFS is still active. Yes, okay, sorry. And update this setup. Okay. So now, hopefully, we should be able to submit this job. Oops. Submit puts up. Okay, a third job has been submitted. And the worker nodes should be able to see CVMFS. We have also an internal way to check if everything is working. If you're interested in these details, you can get the pod's name of the worker node from inside the cluster. And then we can check from inside, we can say exec inside this worker node and run ls cvmfs. Bash -c, this one. Okay, there are some problems with CVMFS. I can't actually tell you why, because before just worked, but okay. Nothing new. Without losing too much time in here. Yeah, I don't know how this can be possible, but okay. I hope that also with this online problem, you get the picture or the purpose of what I was showing. And yeah, okay. And then we can go on with the demo just here with the last step. That is okay. The Jupyter went up correctly, and we also are provided by with an address when we can reach our hub. And you can see that you can now log in, and you will be redirected again to the legal IAM. I was already logged in, so I just here. And there are a lot of supporting images. These are the 3 suggested ones. And we need only to use simply the notebook with HTCondor, because this is what we want to test. And ask the service to start. So you can see here that our Jupyter lab is starting, and it's bringing up a volume, downloading the images, and we will be briefly ready to go. Coming, yeah. Okay, so started, should be up in a while. I just want to check if by any chance the previous command worked, but I'm not so confident. Yeah, no. Excellent. CVMFS didn't come out correctly. If you're interested, later I can try to fix things up, but I think we are running out of time, so I try to wrap up quickly. So, okay, here you are. We can launch a terminal and check that I'm able to contact the cluster, basically. So you can see here, you can contact the cluster without touching anything, just with the integration provided by the combination of the two Helm charts that I shown you just now. And so you can start notebooks and works with your preferred software and then submit jobs, for example. And this is possible simply combining two of the application. You can have much more. You can create something similar to what AMS and CMX Experiment is doing. That is basically, if you want to take a look, we can go simply here. CMS Experiment is a simple configuration specific of the HTCondor case. So you take the HTCondor case and you put a specific custom configuration for your use case, where, for example, you enable squid servers, you enable CVMFS, and you only enable worker nodes. You remember in CMS case, we want only a pool to worker nodes able through a custom configuration to register to the experiment pool of resources. So what you need to implement your use case, simple as that, taking an already existing chart and configuring it like this, or creating your own Helm chart with your configuration, and you can put this into the machinery and appearing here in the catalog as an icon, okay? And you can use it to deploy and to share your deployment across many providers or many resources. So I think I am almost out of time, but let me just try out. Oops. Okay, no, let's, first of all, before trying out things, I have one last slide that in practice is what I already told you. You have two ways to adopt these solutions. One is, okay, I use the bottom and already, let's say, customization that are already present, but I want to use my own Docker image, and this is this case, and it is supported, as you already saw. For worker nodes, I can use my own image. That's perfectly fine and doesn't need any intervention at the chart repository level. Or I know that I can achieve my results combining the existing ones with an additional one, and I want to put all together in one Helm chart with my, let's say, with my big icon in the catalog. You can do that, setting up basically your own Helm chart. And in case of needs, of course, DODAS team is at your disposal and for any guidance or integration solution. So I've done. I don't know if there are any questions. In the meanwhile, while you think about questions, I can try to finally get this to work. Yeah, please. No one? Everything clear?
Yes. Excellent. Thank you very much, Diego.
No problem, and sorry for this.
No, this finally works very well. We have a question from Sebastian. Sebastian, I unmute you. You can talk to Diego directly. Can you talk?
Hi, hello.
Yes, please.
So what are the next plans for DODAS? Is there a public roadmap or something that we can see publicly to see where the solution is going?
Well, there is no roadmap in the sense you mean, because we are open. Basically, the solution is this.